Hello everyone. In today's video tutorial, I'm going to show you how to create a serverless application that will replicate data from a DynamoDB table to an Elasticsearch cluster. The architecture consists of three AWS services: DynamoDB table, Lambda function, and Elasticsearch cluster. We're going to make use of DynamoDB streams so that the Lambda function received an event every time we change the data on DynamoDB. After that, the Lambda function will copy or replicate the data to an Elasticsearch cluster when we can query the cluster. We're going to be using the Serverless Framework for development and deployment, so it is necessary that you set up the Serverless Framework before starting to do anything. So if you go to this link, you will have a step-by-step guide how to do that. So now let's go ahead and start creating our application from scratch. Serverless Framework, so let's generate a new project. Gonna ask us to generate the project. We're gonna choose Python. We're gonna name the project. Let's name this project DynamoDB Indexer. Now here, and let's open up our project. Let's start creating our application. First, we are going to clean this up. There are too many comments there, just to leave it to the very minimum. We can also delete this section. We're going to create the functions anyway later. So the first thing that we're going to create will be our DynamoDB table. So let's go ahead and declare it here. I will just copy and paste a definition that I have created already. This will be a very simple table named episodes to store serious episode information. So we are naming our table with the service name. In this case will be DynamoDB Indexer. After that, the stage information by default is dev and episode. The billing mode will be paper request. That will be cheaper for testing. And then here we are defining the attributes. In this case, Dynamo requires to define the primary key. In this case is the hash key, right? That will be our ID. And here we are declaring our stream, right? This will be the stream that we are going to be using from the Lambda function. So with that, let's run this and see what happens. Oh, first, before this, let me add a few lines here just for making the command line more simple, right? Here we are declaring our default staging named dev and our default region US East 2, right? So now let's run this, deploy. Oh, so we need to cd into the directory SLS. No, I don't want to monitor this. Okay, I will run the command again, SLS deploy. And let's wait for the deployment. The first time it can take a little bit of time. So I'll probably pause the video and come back when the deployment is ready. Now that our deployment is ready, let's go to the AWS console to see the DynamoDB table created together with the stream. Here is our table. This is the partition key that we declare, the ID, and this is the stream that is enabled. Our next step now is creating the Lambda function and binding it to the DynamoDB stream so it can receive data every time there is a new change in the DynamoDB table. Let's go ahead. I'm going to copy again the code for the function. We're declaring the function here, we're naming it indexer, and then this is the very important part, the event section, when we are declaring that this function is gonna get triggered every time there is a new data in this stream, right? We're getting the string ARN this way from this table, right? Now we need to name our function index. We are going to simply print whatever is coming in the event, right? Now we're missing something here. For the function to be able to communicate with the DynamoDB stream, the role that is assigned to the function needs to have these permissions. If not, it won't be able to get data from the stream. Now let's go ahead and run this. Deploy. And let's wait for it to finish. After our deployment is done, let's test that our Lambda function is able to get DynamoDB streams data. So let's go and create a new record here. So our ID will be 001. Let's name this. Let's create a title here. Let's say Frozen Face Off. That will be the title of our episode. Let's go and say, okay, the series attribute, SpongeBob SquarePants, right? My favorite series. And let's save it. So this is working correctly. We should see the event print out in the console, in the log group. Let's go here, and here is, right? Now let's go and see how that event looks like. Let's replace that. Say this is JSON to format this better. Format document. Okay. And this is the record that we get. The event name is the type of event. This is very important because we will be taking this into account for doing the respective operation in the Elasticsearch cluster. And then we have DynamoDB. Inside we have the new item. This will be the data that is coming new. Our next and final step will be creating the Elasticsearch cluster, right? We need to create the cluster and then modify our Lambda function so we can ingest the data into the cluster. For that, let's first declare the Elasticsearch cluster. Let's go back here, and again let me copy the Elasticsearch cluster definition. Okay, let's go over it very quickly. Here we're saying, okay, our resource type will be an Elasticsearch cluster. This will be the volume size, how many instances. This is the smallest instance size that we're declaring. Be aware that this is gonna cost you money because Elasticsearch is no is not free. And this is very important, danger zone. That's why I'm putting this here. Please don't do this on production. I'm doing this so we can query very easily the cluster, but this is not recommended to do. And even though you might think this is secure because I can only query from my IP, but this is not really recommended. So now that we declare our Elasticsearch cluster, let's go ahead and deploy it. And this is gonna take a lot of time. It may take more than 10 minutes at least for the test that I have done. So I'm gonna pause the video and going to come back when the cluster is created. After our cluster is created 15 minutes later, let's go to the AWS console and verify that our cluster is there. Okay, here it is. We're gonna need this later on. So now that our cluster is created, our final step is to modify the Lambda function. So whenever it gets information, data from the stream, it'll replicate that into the Elasticsearch cluster. So for that, I'm going to copy the Python code in here. I want you to concentrate on what we are doing here. You can take a look at the details later on the GitHub repo. So you remember this event has a records object is when everything is included, and then we can find the ID inside the key, and in new image is where the new data will come, right? So what we're doing here is saying, okay, if the event name is removed, we're going to remove the document from the cluster. If not, we are going to override it. When it's new, it's going to create it. When the document exists, it's going to override it. As you can see here, we're using two custom libraries, request and this library. So this library won't be included out of the box in the Lambda runtime. So we need to make sure that when we execute the function, it'll be pre-installed there. So for that, we are going to use serverless plugin named Serverless Python Requirement that allows us to install any dependency with a requirement file, right? So here we are saying, okay, we want to have these two requirements. To be able to use this plugin, we need to install it, and for that, we need to use npm. First, we need to initialize npm locally. And after that, we need to install the dependency. Okay, we can see here in package.json that we have installed successfully the serverless Python requirement. The other thing that we're missing here is the permission to the Lambda role, because right now if we try to run this, it'll fail because the Lambda function doesn't have access to do any operation on the Elasticsearch cluster. So for that, we need the 3 lines. And let me check. Okay, we are ready. So let's deploy again. After our deployment is done, we are ready to start testing our application. But before we do that, we are missing one configuration. We need to set up our cluster endpoint in our Lambda function. There is an environment variable. We can see it here. ES host, and this is how we're getting it. That is the Elasticsearch cluster domain name. So we need to go here, and here is. Okay. Save it. Now we're ready. Now let's go to our DynamoDB table. Let's modify this record. Let's say we want to add a new attribute, episode 156. If we go to our CloudWatch, okay, here is our record. It is, the event name is modifying. So if our record is correctly inserted in our domain cluster, let's query our cluster and make sure that the data is there. So we grab this URL, we put the index, now the type, now we'll write this correctly, episodes, and then the ID 001. All right, this is the attributes that we have in our DynamoDB table. We can see it here. Okay, episode ID, series, and title. Episode ID, series, and title. So of course this is not cleaned up. As you can see, it has the type that DynamoDB sent you as part of the event, but that's something that you can do very easily in the Python code. I hope you enjoyed this video tutorial and see you in the next one. Hasta luego.